Now we know nucleophiles and electrophiles react. So we're going to combine this together into reaction mechanism steps. And when we write these reaction steps, we're going to be using curved arrows to show electron flow. This is something that's not completely new to you, as we started using curved arrows in resonance structures, and then we also used them in acid-base reactions. So as you do this, one thing I want you to keep in mind is to avoid sloppy arrows. And what I mean by that is they need to be exact. Small deviations in where you start your arrow and land your arrow will make that step, or the curved arrow for that step, entirely wrong. So if an arrow needs to be pointing at an atom, it has to be pointing at that atom, not into space, not at the bond, not somewhere else. So we are very, very careful when we draw these arrows. Let's take a look at a nucleophile and an electrophile and see how they react. So here I'm going to use this oxygen as my nucleophile. I'll draw its 3 lone pairs, and it has a negative charge. And then as my electrophile, I'm going to use bromoethane. And that bromine also has lone pairs. As you're getting started with reaction mechanisms, it can be very helpful to draw in all of your lone pairs. As you get more comfortable, you can start to leave them out. So identify your nucleophile and electrophile, and we know how to do that now. And then what we want to do is start at our nucleophile, and I'm actually going to highlight these lone pairs, one set of lone pairs in red. We could pick any of the 3, but that's where I'm going to start. And I'm going to put my pencil down at this lone pair and draw a curved arrow to the electrophilic carbon. Right there. From here, don't forget that the electrophilic carbon also has 2 implied hydrogen. I can draw those in just to keep track of them. And now hopefully you can see that the carbon has 4 bonds. It can't just accept a 5th without losing a bond. So what I'm going to do is highlight the bond between the carbon and the bromine. And what will happen is those electrons will leave that electrophilic carbon and go into the bromine as a new lone pair. So let's track what's happened as we draw our products. I'm going to draw the oxygen. It already has 2 lone pairs we didn't touch. The red lone pair formed a new bond, and it formed that bond with this electrophilic carbon that I've highlighted in blue. So there's that carbon, and we have 2 carbons there. So there's the first carbon of ethane, the second carbon of the ethane group. Then the byproduct is Br minus. Now that bromine already had 3 lone pairs. Now it has a 4th, which comes from the bond in pink. 4 lone pairs and a negative charge. Right here we have the new bond that was formed. As far as how we look at these curved arrows in the reactants, the red arrow is showing a new bond to the carbon. This pink or purplish arrow is showing a new lone pair to the bromine. Just a couple of other notes. The tail of your arrow must be on a lone pair or bond. And that's what we have here. Here the tail is on this lone pair. Here the tail is on a bond. The next thing, the head should show formation of a new bond or lone pair. And that's exactly what we have here. Here the head's showing the formation of a new bond. Here the arrowhead showing formation of a new lone pair on the bromine. The final thing is with carbon and octets. So like we saw up here, carbon can't have more than 4 bonds. So if an arrow lands on this carbon, electrons must also leave that carbon. You can't violate its octet. And that's what we see right here. So if an arrowhead lands on a carbon with 4 bonds, an electron pair must simultaneously leave that carbon because you can't violate carbon's octet. Carbon can't have 5 bonds.